Hi there, Vinnie from Graphite Note, and today I'm going to bring you through how to set up a lead scoring machine learning model in Graphite Note. This will allow you to take your historical leads, train a machine learning model as to what good looks like, and then to map future leads against that model, so you're going to get a probability percentage of a lead converting, allowing you to focus your sales team on the leads that are most likely to convert and to get in there ahead of your competition. So to start, I'm on the homepage of Graphite Note, and I'm going to go to import demo dataset, because what we have in Graphite Note is a series of demo datasets available for you to try any model within the platform. So you'll see here, there's 12 demo datasets in total. There's an overview of the dataset or description, the use cases it can be used for, and the models that it can be applied to within Graphite Note. So you'll see for lead scoring, this is data on potential customer interactions. It's used for lead scoring and conversion rate optimization, and you can use this data set on these models. And for lead scoring, we're going to start with binary classification. And how do I know that? Well, if I go into the tutorial for the lead scoring model, you'll see how to step-by-step on how to create the model, and a lead scoring data set is required to run a binary classification analysis. So that's the model that we're going to use here. So if I go back to my lead score and import the sample data set, that's now going to appear on my home screen of my Graphite Note instance. And now I'm going to go and create a model. Before I do, you'll see there are 29 columns of data, 9,240 rows. But most importantly, we need a column where we can target the model against. So in this instance, for lead scoring, we need to understand if leads converted or didn't convert. So we're looking for that yes, no aspect. So I'm going to go into models. I'm going to run a new model, and you'll see here the pre-built models available within Graphite Note that are just waiting for data to be plugged into them. So for the binary classification model, I'm going to select that. And you'll see here a minute ago, I uploaded this demo dataset. Click Next. I'm going to classify it. Or name it. And then it's going to bring me to the scenario. So in the scenario, I'm setting the target feature. So we know that from our tutorial in the demo datasets, that converted is the column that we're training the model against. This is an analysis from that dataset of the no conversions and the yes conversions that are going to be used to train the model. Also, you'll see here in Graphite Note, before a model is run, depending on the type of model, the features that are not fit for the model are excluded automatically from the model. So next, and then I'm going to run scenario. Now, I've already prepared this model. It took about 3 minutes to run, maybe 2.5, 3 minutes. And this is the result. So when the model is trained, the first thing I want to do is go into performance. And what this does is this tells me the key drivers behind conversion from my historical data. So you'll see that the first key driver is total time spent on website, which might sound obvious, but it's not necessarily the most time spent on the website. This is the sweet spot time on the website that increases conversion 2 times more than any other factor in this data. Lead profile is also very important. Lead origin is incredibly important by the looks of it, because the leads coming from lead ad form are converting at 2.7 times more than any other column in terms of importance from the data set. Last notable activity, when an SMS is sent. So for some reason in this data set, SMS is having a huge impact. So what's happening here is we're getting tailored insights based on our data only, no external factors. This is the artificial intelligence algorithms going in and getting deep on data insights or patterns or trends or data points in order to develop these deepest insights. There are a lot of other tabs you can go through as well if you want to get into more detail, but this is a strong, solid score. Anything above 60% is statistically significant. So in predictive analytics, machine learning terms, 77 is a standard. If you had 100%, it would be model overfit. There'd be something wrong. So this explains, you'll understand from each of the boxes here, we have actually an explanation or information feature behind them. So the next thing I want to do is I want to go and I want to predict my lead score against the model. So what this is a what if observation playground. And what this will tell us is for each lead type, if there's going to be an opportunity to convert the probability percentage, what it is. So in this instance, from this profile of a lead, you'll see converted as no with a probability score of 86%. If I change last notable activity to SMS sent, and I have time on the website is 100 seconds, now I'm at more of a 50-50. If I say lead source is, let me just see whichever one of it, lead origin is from a lead ad form, and I predict, now my converted yes is going to a probability of 90%. So whatever's happening on lead ad form or behind that, that's bringing people, that's a really important marketing asset, whatever the team are doing to attract those leads, because those leads are converting at a really high probability. You can import a full data set, or we can connect to your CRM or via database connectors to other sources, Postgres, MySQL Server, etc. And the key here is to be able to understand the process we've gone through. We've taken a sample demo data set, and within minutes, we've created a machine learning model that's giving us the deepest insights available on the drivers of conversion. And then what we've done is we've mapped a future lead against the model in our prediction tab. And that's allowed us to be able to predict the probability of the leads converting. So scenario is every morning, the sales team come in and they get access to the leads with the highest probability in ranking order. And they go after those leads first, because not all leads are the same and they shouldn't be treated as the same. I hope you found it useful. At any stage, if you have any questions, please feel free to reach out to me. In our website, you'll see, and in resources, we have a docs section, which will answer pretty much all the questions you have, including the demo data sets that I just brought you through there. You'll see the lead scoring one, and it gives you the step-by-step on how to complete each model. I hope you find it useful.